Okay, today we're going to talk about the rules of exponents. And before we get really started on them, we want to kind of define what an exponent is. And to do that, let's think back to addition. If we wanted to add up 2 plus 2 plus 2 plus 2, isn't that the same as saying 2 times 4? Okay, because we've got 4 2's added up together, and that's how we define multiplication. So therefore, multiplication is shorthand or a short way of writing addition. Well, exponents work the same way. Okay? So in this instance, if we have 2 times 2 times 2 times 2, that's the same as 2 to the 4th. Now, let's talk about the parts of an exponent. The first part of an exponent is what we call the base. And to remember this, remember it's the big number or it's the variable or number on the bottom, okay? And it's the bigger number of the two. And then the other number is the exponent itself. I'm misspelling it. Exponent. And that's a small number on top. Now, the base is the number that you're multiplying, or the variable that you're multiplying by itself. The exponent is the number of times you do that. Now we can talk about what we call the product rule. The product rule, let's say we have the problem 2 to the 4th times 2 cubed. That means we have 4 2's multiplied together, 2 times 2 times 2 times 2. And then we have 3 2's multiplied together, 2 times 2 times 2. And those 4 2's are multiplied by the 3 2's. So what we really have is 2 to the 7th power, because we have 7 2's total multiplied together. So what that means is that if I have 2 to the 4th times 2 cubed, that's equal to 2 to the 4 plus 3 power, which is 2 to the 7th power. Okay? And that's really the definition of an exponent. So this gives us our product rule for exponents, which says if we're multiplying two exponents with the same base, we can add those exponents. So let's practice on this. Our first problem here is 2 cubed times 2 squared. Well, 2 cubed times 2 squared, that would be 2 to the 3 plus 2 power, which is 2 to the 5th power. Next, if we look at x squared times x to the 4th times x, remember we have a little invisible 1 here, okay? So we can have x to the 2 plus 4 plus 1 power, which is x to the 7th power. Thirdly, we're going to have 2y cubed times 4y to the 8th. Now, when we have coefficients in front of our exponents, we need to multiply those first. So that gives us 2 times 4, which is 8, times y to the 3 plus 8 power, which is 11. So 2y cubed times 4y to the 8th is 8y to the 11th. Using that same procedure on a slightly more complicated one, we see what happens when we have multiple exponents that we're multiplying. So here we have negative 4a squared b to the 3rd power times negative 3a to the 5th b to the 9th. And I like to work it in this order. I multiply my coefficients, which are my numbers out front. So negative 4 times negative 3 is positive 12. Then next I multiply the next variable, whatever it happens to be. In this case it's an a. So a squared times a to the 5th gives me a to the 7th. And then I'll work that second variable. B cubed times b to the 9th gives me b to the 12th power. Okay? So 12a to the 7th, b to the 12th power. Next rule we want to talk about is the quotient rule. And what if we want to simplify a problem like 2 to the 5th times 2 to the 3rd power? Let's zoom in on that and look at it a little bit more closely. So if we have this problem 2 to the 5th times 2 to the 3rd, what we really have here is 5 2's multiplied together on top. So 2 times 2 times 2 times 2 times 2 times 2. And on the bottom we have 3 2's multiplied together. 2 divided by 2 is 1. Another 2 divided by 2 is 1. Another 2 divided by 2 is 1. And we are left with just 2 times 2, which is equal to 2 squared, which is just 4. Well, if we look at this 2 squared and look at 5 and 3, 5 minus 3 is 2. So, and looking at our canceling, we took 5 2's, and because of the 3 that canceled out on the bottom, we only had 2 left. Okay? And so that's how the quotient rule works. Let's do some practice problems with this. Whoa, what did I do there? Okay, x to the 7th divided by x to the 4th is just going to be x to the 7 minus 4 power, which is x cubed. Next, we have 2x to the 9th divided by 4x cubed. Now here, we still have to cancel out our coefficients. So 2 goes into 2 once and into -4 -2 times. And then x to the 9th over x cubed is going to leave us with x to the 6th power. So we end up with the negative of x to the 6th over 2 power. Thirdly, we have 2x cubed to the 0 power. Well, anything to the 0 power is just 1. Next, we want to talk about the power rule. What happens if we take an exponent to a power? Well, here I have x cubed, and I've got it squared. So that means I have x cubed times itself. Well, if I have x cubed times x cubed, that's like saying x times x times x times another x times x times x, right? If we break it down all the way. Well, that's just x to the 6th power. And if we look at 2 and 3, 2 times 3 is x to the 6th. And we call this the power rule for exponents. If we have an exponent taken to another power, we can simply multiply those powers together. So 2 cubed to the 8th power should be 2 to the 24th power. X squared to the 5th power should be x to the 10th power. It gets a little weird when you have combinations of this. Here we have 3x to the 8th times x cubed to the 6th power. And applying PEMDAS, I'm still going to take care of the exponent here first. That gives me x to the 18th power times 3x to the 8th. Okay? Well, now x to the 8th times x to the 18th times 3 is just going to be 3 times x to the 18 plus 8, which is 26. Okay? Let's look at the bottom here. More rules of exponents. It doesn't matter what you have as a base, whether it's a single item or the product of many items. The power rule still applies. So, here we have negative 2x squared squared, which means we have 2 negative 2x squareds multiplied together. Well, using my basic rules, negative 2 times negative 2 becomes 4, and x squared times x squared becomes x to the 4th, which gives me 4x to the 4th power. Okay? And that same power rule principle applies to the quotient rule. It doesn't matter what your base is, it can even be a quotient, okay? So if I take a quotient, like 2x divided by 3y, and square it, I'm still going to have 2 of those multiplied together, which results in what's inside this original parentheses being squared. Just like up here, what was inside this original parentheses got squared. So 2x over 3y times 2x over 3y means I'm going to square 2 and get 4, square x and gets x squared, square 3 and get 9, and square y and get y squared, which gives me 4x squared over 9y squared. So let's apply this to some other problems. Here we have negative 6 times b fourth cubed over 3b squared. Well, I'm going to take care of this top thing first before I take care of my quotient, because I take care of exponents before I divide. So that gives me negative 6b to the 12th power over 3b squared. Now I can apply my quotient rule, which gives me negative 2b to the 10th power. For number 2, we have 5x cubed y squared cubed. So that means I need to cube everything inside those parentheses. 5 times 5 times 5 is 125. X cubed is 3 times 3, which is 9. Y squared cubed is y to the 6th power. Okay, now we're going to go on to problem 3. Looking at problem 3 here, 2x squared, or negative 2x squared over 3y to the 4th power. Again, we're going to have to take everything to the 4th power. So 2 to the 4th power, 2 times 2 is 4, times another 2 is 8, times another 2 is 16. So 16. X squared to the 4th power is going to be x to the 8th. 3 to the 4th power is 81. And y to the 4th power is just y to the 4th power. And if we have a negative 1 to the 4th power, that's going to end up being positive. And so my negative sign goes away. Now we're going to talk about negative exponents. First of all, let's think about the quotient rule. What would happen if my top exponent was larger than my bottom exponent? Well, let's think about this. If I had x to the 5th power over x to the 7th power, and I was going to apply the quotient rule, that means I have x to the 5 minus 7 power, which is just x to the 5 minus 7, which is negative 2. So what we see is that negative exponents in the numerator are actually positive exponents in the denominator. And what I mean by this is that when I'm looking at this and I cancel everything out, I end up with 1 over x squared. Okay? So, if I have a negative exponent in the numerator, 1 over that exponent being positive in the denominator is the same thing. It also works if you have a negative exponent in the denominator. So 1 over something to a negative power is actually that thing to a positive power in the numerator. Okay, what this means is we have a rule, kind of a shortcut that we can take this. If the negative exponent is in the numerator, or on top, move the exponent and base to the denominator and make the exponent positive. If the negative exponent is in the denominator, or on the bottom, move the base and exponent to the numerator and make the exponent positive. Okay, so let's practice this moving and make our exponents positive with these practice problems. Practice problem number 1, 2 to the negative 5th power is actually 1 over 2 to the positive 5th power. Negative 2 to the negative 5th power is 1 over negative 2 to the positive 5th power. Okay? I'm going to get a little tricky with this. Negative 9 to the negative 2 power. Remember, with PEMDAS, we are only going to tackle the exponent part. That negative is actually negative 1 times 9 to the negative 2 power. So I'm going to end up with negative 1 over 9 squared, which if we deal with this is like negative 1 over 81. Here we go. Here we have a negative exponent in the numerator and 1 in the denominator. Well, the 1 in the numerator moves to the denominator to become positive, and the 1 in the denominator moves to the numerator to become positive, and so we end up with 9/8. I hope that helps you understand the rules of exponents. This should cover 2 lessons, and we will get lots of practice in class.